Let's just frame the problem with some really depressing statistics. And so these numbers are from 2011. Things have not changed that much. Most of the stuff we build in the context of mHealth doesn't get used very much. Majority of the applications are abandoned by temp use, and a full quarter of them only get used once and then deleted off of people's phones, right? So this is not great. But in particular, if we're interested in supporting long-term behaviors like preventing relapse from substance use or health behavior change around physical activity or diet or obesity management, these kinds of numbers are really not going to cut it. So if we're going to help people with the health problems that we're trying to target, we need to do better about creating interventions that individuals are willing to use over extended periods and stay engaged with them. And so what I want to suggest in the rest of this talk is that design is going to be a way to address this problem. And it's really the main question we're trying to deal with here is how do we design mobile technologies in a way that they don't end up abandoned of a drawer. And I think design actually helps with this. So just so we're all on the same page, I want to start with the big picture about what we actually need, and then I'll walk you a little bit through the process of how the user-centered design work. Then we'll talk a little bit about some of the core concepts that you should be keeping in mind and some strategies that can be used to facilitate engagement. So one of the probably best definitions of design from my perspective is this quote from Steve Jobs, who basically says that, well, most people think about design as how something looks, right? So the visual aspects of design. Really what we should be focusing on is that design is on how something works, right? So this is really, really key, that when we're talking about design, we're talking about functionality, how that functionality is implemented, how individuals engage with it, and sort of how the system allows a person to accomplish the goals and tasks that the system is intended to support. And the other main thing to note is that you should think of design as a process. So there are some people who are really, really talented in relation to design, and so we often, let's see this, we can get a little bit less feedback. Sometimes we think that really without that kind of talent you can't do good design. So unless you're Steve Jobs or Johnny Ive or collaborators, that you're not going to be able to do good design. And I'm here to tell you that really a lot of what ends up being valuable about user-centered design can be accomplished by following processes, right? And that having some understanding of how the process of design work can get you a long way toward creating things that are well designed, that are usable by individuals who try to support. And in particular, you can sort of think about that the design contains four main stages. Right? There's the whole conceptual part about framing the problem, just trying to figure out what is this problem that you're trying to solve. And a whole bunch of time in any kind of design project ends up being spent revisiting this question. What's the actual problem that you're trying to solve? You might start with one understanding of the problem, and then as you're working through the process, realize that actually what you should be focusing on is something slightly different, or that there's only one aspect of the original problem that is the key component that you should be focusing on. And all of those reformulations of the problem are going to have downstream effects on what you end up doing in terms of the solutions, right? So really thinking through what the problem is and revisiting that question over and over again over the course of the project is key. The other big part of the design process, and I think this is actually one of the things that is unique to the design process, is this notion of ideation, and which has to do, and I'll be going into this in a little bit more detail, with systematically exploring alternative ways that something can be done, right? So sort of creating a large set of solutions that you can consider and choose among before you commit to a particular trajectory on how to proceed. Then there's work around selecting a good solution. So once you've actually generated a bunch of these things, you need a way to evaluate them, right? To consider their pros and cons to decide which way to go. And then once you have a direction that you're moving in, there's a whole set of processes around how to refine that solution, right? So around creating prototypes iteratively, getting feedback from users, so that you end up with something that is of high quality and robustly solves the problem you're trying to solve. At the start of all of this is what in user-centered design we refer to as formative work or user research. but basically trying to do the work that is required to deeply understand the context in which you're working, right? So that the users, the needs that they have, the constraints that they're dealing with, and the various other aspects of the environment that would influence whether a particular solution is likely to work or not. We have a number of different strategies that we can do this. Some of the classic ones are interviews, running focus groups, doing observations, shadowing people. All of these methods can be used, as well as sort of online research and going to the literature, to collect a set of materials about that provides you with some sense of what the constraints are that you'll be working with, what the needs are, and how those needs are situated in different subgroups of the population you're trying to support, and what are the key problems that you should be. Now, what is nice about user-centered design is that it actually provides you with some techniques and methods of taking all of this information that you've collected as part of your formative work and systematizing it and sort of managing it in a way that creates a bridge towards the functionality that you're trying to build. And there are a number of these methods that can do this, but I want to focus on a couple of them right now. One of them is this notion of personas, and some of you might be familiar with this. You can sort of think about personas as fictional characters, but fictional characters that are based in your data, that represent different classes of users that you're going to be trying to support. Okay, so they're people that you're inventing, but they're really sort of, you can think of them as archetypes of different user groups within that you've discovered as part of your user research that might have different needs in respect to the solution you're trying to build. And so personas then get formalized in these kinds of persona sheets that provide a little information that concretize who these people are, right? So you have, in this particular case, Mary, that we have some demographic information about. We know her age. We know roughly the profession that she's in. You also have particular motivators that are influencing how Mary is going to be using the thing that you're developing, and sort of the motivations around the problem you're trying to support. So a lot of in the context of health technologies, sort of the motivations might have to do with why they're trying to change the behavior, what kind of constraints they're working and living within, and what other things you might need to take into account to design something that Mary is actually going to be able to. So both the motivators and constraints end up being really key parts of this. What's nice about personas is it allows you it gives you a very quick mental shortcut to have some early checks on the solutions you're trying to develop. So if you come up with a feature that you think might be a good match for the problem you're trying to solve, you can sort of very quickly ask the question: is this something that Mary would actually find useful, right? And insofar as the design team has these representations as shared understandings of who they're trying to support, it allows for really effective communication across the design team about what might and might not work before you actually go and test individual prototypes with end users. So this allows you to make that initial bridge from just collecting a bunch of information in the form of your work, and then starting to have a check on what might be effective for different subgroups of people within that population. So key characteristics of personas, again, is that they're based in data. They embody goals, traits, and behaviors that influence how technology is going to be used, and they represent distinct classes of intended users. Sometimes you only have one or two personas. Sometimes you have 5 or 6, right? Depending on the kind of solution that you're trying to develop. But in any case, you're trying to isolate subgroups that have different needs, and that you will need to be taking into account as part of your design. Another really effective tool for dealing with the data that comes out of formative research are scenarios. And this is going to be very verbose on this slide, but basically the thing to take from this is that you can think of scenarios as short stories that you can write about what you're discovering in your formative data, that would start bringing you closer to the kinds of goals that individuals that you're trying to support are pursuing, and how a technology might fit into how those goals are being accomplished, right? So I'm not going to go through this in detail, but the kinds of things that you need to be keeping in mind is that scenarios have setting, right? Sort of where something is happening. You always have agents. There is someone in the scenario who is doing something, right? That might be user, that might be another stakeholder who's interacting with the user. There are always goals of what the agents are trying to accomplish, right? So the stories are very targeted at trying to demonstrate how an agent is pursuing a goal, and how either that is happening in the current situation, in the case of problem scenarios, which is one of class of the scenarios that get designed as part of this work, or how the things might look different once you actually have the technology that you're envisioning, right? So this allows you to start thinking. What personas do is they give you a sense of the users that you're going to be using this. Scenarios now take you one step further towards the actual solutions you will be developing. Okay, so they're also based on informative research. They're based on the understanding of the users you're going to be helping. But you're now trying to fill out what would these people do differently if they had certain kinds of solutions. What is key to note about both personas and scenarios is that they're relatively inexpensive design representations, right? You can make these things relatively quickly. Okay? It took me, when I was writing that particular scenario, I think it took about 10 minutes to put this together, right? You can write a bunch of these. You can write a bunch of them very quickly, and then look at them and say, you know, I can buy this one. Now, this one doesn't sound compelling at all, right? And so it allows you to start shaping your thinking about the classes of solutions that you're going to be pursuing in a relatively quick and iterative way, so that you don't get stuck on the first thing that comes into your mind, right? And we'll be coming back to this idea in just a bit. But it allows you to now ground those intuitions about what might be needed in real data through concrete design representations that can be shared with other members of the research team, that can be then fed back to the end users for feedback. It's like, is this realistic, right? Could you see yourself doing this? And so you get a check on your on your intuitions of what might be needed for that population. The other key set of methods that you should familiarize yourself with are ideation methods. And again, the way to think about ideation is that it's a process of creating a lot of concepts in a particular space, right? It gives you a lot more choices from which to generate a high quality solution. And the grounding for this, now there's a fair bit of empirical data around ideation to show that really when we do this kind of parallel prototyping, right, when we create a bunch of solutions initially and then we choose from those solutions, we end up with much higher quality solutions than if you just sort of start with one thing and then iteratively refine that one thing over and over. And Stephen Dowd, who is now at UC San Diego, did a fair bit of empirical work showing just how valuable ideation is in terms of both the quality of the solutions and sort of how much self-efficacy individuals feel in the design process. There are a few very basic rules of ideation. One is that the whole point is to make ideas cheap. Right, so you want to generate as many ideas as possible, so that you don't get attached and wedded to any particular idea. That you're willing to get rid of the stuff that's crap. Okay, this is key, right? The reason to generate a lot is that you can throw away a lot. We all have the tendency to really get attached to our ideas, right? And then we will massage the hell out of them to make them work, even if they're actually not the right idea. The point of ideation is to prevent you from doing that. So if you can come up with a whole bunch of new stuff in a minute's time, you don't need to be wedded to any given idea, right? You have a much larger space from which to work and from which to choose things that are really good. And in order to make them cheap, right, you need processes that allow you to generate it, right? Which means that you often, as during ideation, only fill out some of the basic features of the idea, so you have something to play with in your mind, without really fleshing out all the details. And what you can do is both generate variations on a single idea, as well as sort of highly diverse ideas for a particular solution. So ideation can be done at a number of different levels of abstraction, right? You can ideate the whole classes of solution. What kind of things might you want to do to support a particular behavior. You can also do ideation around how a particular feature is going to work, right? And the same kind of process ends up playing out at any of those levels. You basically use methods to allow you to just quickly generate a bunch of things and then choose among them. Right? And as you're doing ideation, you don't worry about the quality or feasibility of it. This is key. So any of you who have done brainstorming or have tried to sort of quickly crank out the first draft of a paper know that if you stop and edit, you get stuck, right? So the idea here is to really try to get stuff out of yourself first, and then you sort of put a critical hat on and you choose among the things that you generate. The problem is that we're all cognitively lazy, right? And so this is actually hard for us. Typically, if we start generating ideas, you come up with the 3 or 4 or 5 things, and it's like, oh, I ran out, right? And so what we've been doing in the design disciplines is coming up with sort of structured methods that allow you to bypass that kind of cognitive laziness. And a number of them are listed here. So sketching is a big one in both interaction design and other kinds of visual design disciplines, where you basically just do very quick drawings with minimal detail that allow you to just cover, to articulate what's the big idea that you're trying to convey. And the little picture I had at the start of this, so this is what sketching looks like, right? These are various sketches of a lamp, right? And what you're seeing is that in terms of the actual level of detail, these are very minimal. You might even, those of you who are visual designers might say that there's actually, in terms of just sort of talent involved in the drawing, might not be might not be a highly technical person drawing, and that's okay, right? So this is actually really important. You don't need to be good at drawing to sketch, right? The point of sketching is just to convey ideas, and because this is not the end product. This is purely a process representation. And so the idea is to just try to create as many of these things as possible, and to really try to understand what the space here is like, right? The brainstorming is another common way of doing this, where ideation happens in a group where multiple people are throwing ideas on the board, and the idea is to basically, there are structures of how to do this effectively, but the end goal is the same. You basically try to come up with as many ideas in a particular domain as you can. Mind mapping, time idea generation. So this is one of those things where you give yourself 5 minutes and you're just trying to generate as many ideas as you can in that amount of time. Or you give yourself a quota, like I need to generate at least 50 ideas of how this can work, right? Those are all tools of how ideation can happen. The end product of all of this is that you want to be generating at least dozens and sometimes hundreds of ideas, those ideas. We're talking a lot, right? 3 is not ideation, right? You need actually to let yourself go beyond the first stuff that comes to mind. Right? That's what makes ideation really effective and really helpful, is to go past that kind of mental laziness of the first things that come to mind and the big things that we solidify in the system. So you need a lot of stuff in order to do that. The other sort of key process in interaction design and design more generally is this notion of prototyping. And the way to think about prototypes is that they're really ways of translating findings from formative work and from the work that went on as part of ideation and then selection from the alternatives into something on which you can get feedback. And to do that quickly, right? Again, there's a meta theme here that we're trying to do stuff as quickly and as cheaply as possible, so we can iterate as many times as we possibly can, right? And prototyping is another technique that allows you to do this, where you create representations of the solution that you have along the way, on which you can get feedback quickly, so that you can change the directions and adjust things as needed. Right? There are several reasons why we prototype. Sometimes you really don't know how something should work, right? And you want to be able to try several kinds of things, right? The second one, and this one is key in the context of mobile health. Software development is expensive and time consuming. It's always more expensive than you think, and it's going to take twice as much time as you think. And twice as much time is the conservative estimate here. Okay, so you want to do this only when you know what you're actually building, right? So prototyping allows you to delay software development for as long as you possibly can, until you actually have a really clear sense of what it is that you're trying to create. And most importantly, in terms of the quality of the things that you're developing, prototyping allows you to get feedback repeatedly and often, right? So that you can make adjustments as you go along. There are a number of different ways that you can prototype, and for screen-based interactions, so if you're designing a mobile app or a smartwatch app or things like that, often these three things, the storyboards, the wireframes, and interactive prototypes are the kinds of things that people end up building. You can think of storyboards as basically cartoons. They're sort of visual representations of how something is being used in pursuit of the goals that technology is supposed to be accomplishing. So you can sort of think of storyboards as a visual version of something like a scenario. Wireframes are really the main ones that we often think about when we think about prototypes. And these are actually minimal representations of how the interaction is going to take place within the system. So we can do this again using software or just sketching, but basically it allows you to concretize how a particular piece of functionality within your system is going to be working, so that you can get feedback on that, right? And then interactive prototypes are really sort of taking things like wireframes and turning it into a representation where you can mimic the actual dynamics of working through the system. And you can do interactive prototypes at a number of different levels of fidelity, starting with what they typically call low fidelity prototypes, where you can use things like post-it notes and pieces of paper and markers to mock up what the system how the system would behave, and then run those prototypes by users. So there's a lot of really nice work that we've done around low fidelity prototypes, showing that you can get extremely valuable feedback by showing people representations like this that mimic screen interactions, but without the user getting bogged down into design details that are at really minute levels, such as things like fonts and colors and so on, because it allows them to really focus on functionality. Are they able to understand the flow through the system? Are they getting stuck? Do they understand what this thing is supposed to be doing, right? And the key goal for low fidelity prototypes is to really try to create all of the key interactions the user would need to go through to accomplish a particular task, right? So if you were designing a mobile app, right, and you're creating a paper prototype of a mobile app, and a user taps in a text field, you want to have a little pop-up for a keyboard, because that's what the user expects, right? So you can actually prototype these interactions at that level of detail, so you can actually tell, is everything, are you actually envisioning all the steps that the user will need to go through in order to accomplish the task that the system is supposed to support. And what in every classroom interaction design I teach, I have my students doing these kinds of paper prototypes. Usually, there is sort of grumbling when you assign this to them. It's like, well, I can just do it in software. Why in the world would I want to do this with paper? And without fail, after they actually do it and they run it by a few people, people just love this thing. They really think it's a highly valuable process, and because it's really quick to do. You can do a pretty sophisticated paper prototype in a couple of hours, and get a ton of information that can very completely change what you end up doing for the next iteration of your system. Another type of prototyping that is becoming increasingly relevant as we're moving towards technologies that include more artificial intelligence and non-screen interactions is something that in HEI we're calling Wizard of Oz prototyping. And really, sort of the way to think about this, the reason it's called, is that there is a man behind the curtain doing something, right? And so the Wizard of Oz prototyping are systems where unknown to the user, this feedback is being given by another person. Okay, so you basically have a human being with all human intelligence and human capabilities, mimicking what the system might actually give back. And the kinds of stuff where you might want to do this is things like, if you're trying to prototype interactions on something like a smart speaker, right? There are no things here. You can do wireframes for a smart speaker. If you have a chatbot where you're really trying to mimic certain kinds of interactions that would be really, really, really hard to code up in a quick amount of time, You can actually have a person on the other end sending text messages, right? Under some constraints of what that interaction would actually be like if it was done through technology, right? In both of those cases, the idea is to try to get a sense of how individuals are responding to a particular technology, how they're interacting with it, and so you can better understand the kinds of responses that the system provide back. How to create your Wizard of Oz prototypes? Well, you really want to create a prototype that can support user input in the format that you're actually trying to support, right? So if we're talking about a smart speaker, right, you want the prototype to be able to hear a person speak, right? As well as then creating mechanisms to prototype the communication to the wizard, and then the feedback back from the wizard to the user of the system. So I'll give you a very simple example. Let's say you're trying to design the next version of Alexa or an application for Alexa. How would you feel Wizard of Oz prototype, right? Well, one very simple thing is you take a cardboard box that Scotch comes in, you put a cell phone in it, right? And that's turned on, right? You dial to the person who is going to be doing who is going to be the wizard, and you let the person talk to the box. The cell phone is going to transmit this to the person can talk back, and you have something that feels very realistic. Like the experience of talking to the Scotch box is actually not that different than talking to an Amazon smart speaker, right? So this, again, very quick, very dirty, but it accomplishes the interaction in a really, really robust way, okay? So as we move towards the kinds of interactions that are going to involve a lot more other modalities, tapping, voice, and so on, as well as when you need a lot of artificial intelligence to make something work, this is a really good way to do prototyping. I want to now go through a couple of sort of key concepts of design that are really worth keeping in mind as you're doing interaction design. The first one of these is the notion of affordances, and this was developed by Don Norman in the early 80s, bringing some ecological psychology in the context of user-centered design. But the way to think about affordances is that they're perceived action possibilities that emerge from how a particular piece of technology sort of looks and feels like, right? So this is the thing that when you look at an object, understanding what can you do with this thing, right? And how, to what extent that is made apparent in the design of the technology itself. A very sort of clear example of this is there's the distinction between something like a command prompt, right, on a computer, and a file finder in on Mac OS, where on the left side, right, this black box, you have no idea what you're supposed to do with this, right? I mean, you can type something, but in terms of actually understanding what you should be typing, what form that should be taking, there's nothing discoverable about it, right? Here, things look kind of like folders, right? There are little triangles that you can poke at, right? There's more about what you understand you should be doing with the interface on the right than on the left. That's really what we're talking about when we're talking about affordances. In the context of mobile design, right, we have these sliders that you, when you see it, you kind of know what to do with it, right? There are little switches that you know what to do with because you have experience with turning electricity on and off. We have these little spinner things that when it pops up, it provides some feedback in terms of your animation that gives you an indication of what you should be able to do with this, right? And the key concept here is that the system is discoverable, right? You by how it's designed, it's telling you something about how you should be using it, right? And affordances are really, really key to how usable and how enjoyable a particular piece of technology is. And when they're done, when you screw this up, right, people get confused. So this is one of my favorite examples. This is a water fountain that is all over the campus in Michigan, right? Many of them are quite low. So you approach this thing, you're trying to get some water, and you have no clue how to turn this thing on, right? You poke in the radio, you poke in the thing. There is a button at the very bottom of it, right? That says push, right? But it's this low, right? So unless you're a 2-year-old child, who is not able to read, you don't see that thing, right? So the affordances here are really poorly done in terms of telling you what you should be doing to get the water out of the water fountain. Another concept that is really key is this notion of defaults, right? So basically how the system is configured out of the box. And the defaults are really represent the state of the system inputs and outputs that reflect the designer's understanding of what sort of the large majority of the users are going to need and want when they first go to the system, right? So you can think of it as sort of the out-of-the-box experience. Think about buying a new mobile phone, right? There's certain ways that those phones are configured when you first open it, right? The ringer is on, so that when someone calls you, it is actually going to ring. You hear the little keyboard click, so you get some feedback about when you're typing. The roaming is turned off, so you don't end up with a whole bunch of charges if you go off of the network and so on. So that's what we're talking about when we talk about defaults. And in any complex application, there's going to be a whole bunch of these things. The reason defaults are important is that they can actually substantially decrease the time that the people need to use your system in order to accomplish a goal, right? And onboarding is a prime example of this. Like if you have smart defaults on when some, in this case, this is an example of this tax acceptance intervention that I designed a while back, where we need to be sending people messages several times a day, right? If I have smart defaults for when those times are that work for most people, you can just hit next and move through this thing versus having to set each one of those things individually. It's a lot of work that you're saving to the users by having smart defaults. The other reason that defaults are really important is because they're very rarely changed, right? Some of these studies were done originally in the 90s, and they've repeated them time and time again since then. And it turns out people just don't change the default state of the system very much, right? So however it is that you design this thing when they first open the box, right? When they first download the app and then they open it up, that's how it's going to be working for them for the most part, for the rest of the time. So you need to be really mindful about how what we do in terms of defaults. They can also have a relatively high-stake implications, right? So think about the default on a Facebook post in terms of who is able to see this. There's a huge difference when you upload a picture and if the default is that picture is public versus if it's only your friends that are able to see, right? And all people can get into all kinds of trouble under one set of defaults versus another. So these are not just trivial things in terms of saving people work, but they can actually have really, really high-stake outcomes. So now back to this notion of engagement, right? And the fact of the matter is that engagement is an open problem. We don't actually know how to solve this, right? But if we did, or someone figured that out, it'd be very, very wealthy, and we wouldn't be here today because we would just know how to do this. But there are a few, I think, guidelines that are worth keeping in mind that can help with this problem. In addition to just creating using good design process to create robust tools that actually address the needs of the people that you're trying to help. One of this is this notion of value versus burden. That they basically, I mean, if you think of it in these terms, every time a person is considering using the system, they're doing this implicit mental calculation of are they going to benefit from the system versus how much of a pain in the butt using this is going to be, right? So what's the value versus burden? And there's some really compelling examples that if you get this ratio wrong, people just abandon the systems altogether. So a lot of the work, this was about 10 to 15 years ago, there was all of this hoopla around personal health records, things like Microsoft Health Vault and Google Health at the time, which were going to just revolutionize how we manage our health because we can integrate all of this information from various healthcare providers and our own self-tracking into one place. So once, if you actually have a healthcare need, you have this thing that now has everything that is needed for you to manage your health. Turns out no one was using these things. And the reason they were not using it is because it was a huge pain in the butt to actually do this, right? There was a tremendous burden in inputting the information, getting the stuff out of the electronic health records into the system, putting all of the results from various labs and so on that were not wired together manually into the system. And for the most part, when you were doing this, you were not getting any direct benefit from these systems, right? You might get some benefits 5 years down the road if you get seriously sick, but the work is now, and and whether you actually need it or not is questionable, and there might be quite a delay before you actually need it. The people who actually needed this stuff, people who had serious chronic diseases, people who had cancer, who needed this information, they didn't have the energy to deal with it, right? So you have a situation where one set of users have high need, but not the capacity to engage with these technologies. And another set of users who has the capacity, who have the capacity to engage with, just didn't see the value of it, right? They only got the burden, they didn't get the value. Patient-reported outcomes research strikes me in many ways in the same way. It's not like we ask patients to do all of these questionnaires that then just get whisked off to the physicians and they never get anything back in return, right? Well, all of the burden is on the patient and they don't get anything. So thinking about design in terms of how do you make sure that the individuals are always getting more value out of the system than the burden that you're imposing on them, I think is a really sort of good heuristic with which to keep in mind as you're doing your design. So one key example for this in mobile health is just all of these applications for diet management, right? Not many people are able to stick with them for very long. And the reason for that is that, again, the value burden ratio changes over time. So initially, when you start tracking, you're learning about your patterns, you're discovering new foods and understanding the caloric value of different foods. You're actually getting a lot of value for putting in the work of inputting the foods into the system. After 2 to 3 weeks, you actually have very little new information is coming back at you, right? The work of logging everything is still there, but the actual benefit that you're experiencing at the time of logging is minimal, right? So the ratio changes and people often abandon it. Another thing that is potentially really useful is something that Facebook has down. Is this notion of novelty. But another way to think about novelty is in terms of schedules of reinforcement for those of you coming from behavioral disciplines. Can we create schedules of reinforcement that actually that keep people using the health technology at a high rate, or at least a high enough rate for the technology to be able to provide the right kind of support? What is also addictive about Facebook is that it's an intermittent schedule of reinforcements, right? Anytime you open Facebook or Twitter or any of these things, most of the stuff you see is crap. But every once in a while, there's a nugget that's actually interesting, and you can never no idea when that nugget is going to come in, right? So we keep packing like a rat. It's like maybe it will be this time, maybe it will be this time, maybe it will be this time, right? And so we can be more thoughtful about how we do this in the for good and not purely for sales of advertisements, but the principle is the same, right? You can actually use schedules of reinforcement and this notion of novelty to shape the usage patterns of technology over time, right? It might be that early on you really want to be, especially in relation to something like creating adherence to self-report, right? You might want to be providing reinforcement on a 1-1 fixed schedule where there's something good that happens to them every time that they provide a response to create initial sort of high level of responding, and then switching that to more intermittent schedule reinforcement where the rewards are less expectable, and it allows people to maintain the behavior over an extended period of time. One huge thing that we keep encountering time and time again is this notion of integration with daily life, right? So when we started doing this work on mobile health, a lot of our sensors were really big and bulky, and we had all kinds of problems with non-adherence to use of the sensors in our studies because they were just not things that people wanted to wear, right? So in some of the early studies that we did, where this little device called MSP was the activity sensors that were sensor we were using. Our female participants basically said, when we wear a dress, there's nowhere I can put this thing. I just can't wear it. Like it's not that I'm trying to be non-adherent. I just can't put this thing on. Right? But even just the quality of the design matters, right? I mean, if you're thinking about a wearable and you're deciding among multiple wearables that might be able to give you the same kind of data for the participants, right? Something that is big and bulky might be less acceptable for part of your population than something that is much more stylish and less obtrusive. Finally, a lot of our newer mobile health applications have, and this is, in all of my experience, been a really two-edged sword, right? Social can be really, really compelling if it's done well, and if it's done poorly, it can vary. it can completely destroy the experience. And one of my favorite examples of this was a project from early mid-2000s by Sunny Consolvo, who was basically building a walking intervention for groups of friends. And what ended up happening is that in a lot of these groups of friends, you ended up with very one or two people will be really competitive, and they will just mess up the dynamic of the group, where other people will just feel overwhelmed and pull back, and they will just disengage from the intervention, right? So being able to manage, if you're going to be using social functionality, being able to manage the social relationships so that you don't get heterogenic effects, I think is really key. And lastly, people have privacy concerns about this stuff, right? The more we use sensors, the higher some of these privacy concerns are going to be, and we need to tackle them heads on. So in all of our work that we've done that examines privacy perceptions, well, we get a lot better results if people understand exactly what is happening, how their data is going to be used. And particularly if they have some agency about making decisions about what is acceptable and what is not acceptable. So you can think of with some interventions, it might be possible to create gradation of functionality, where there's a core of the system that is available at very low privacy cost, right? Maybe using only accelerometers or some other sensors that no one really has a big problem with, right? And then in order to get some of the other functionality, you would need to opt in for the more invasive sensing, but a person is given a choice, and sort of you can explain what the benefit of that would be, and they can make a choice of whether they're willing to engage with that or not, right? So I think the worst thing we can do is to just bury the privacy implications of. I think that's both in terms of ethics and in terms of just creating a trusting relationship with people you're trying to support is a horrible idea. Right, so being there's a lot of work that is gone into creating more privacy-preserving ways of using sensor data, but even with that, I think openness of communication and providing some agency to people is really key. So, just to summarize, the point of design is to create systems that actually meet people's needs, right? You want to create the thing, and that means understanding deeply what those needs are, what kind of constraints people are dealing with, and then creating a solution that fits those needs in a really fine-tuned way. A design process can let you do that by allowing you to refine both have a lot of ideas that you evaluate for match with the needs that you have identified, as well as then once you actually have a way of approaching a problem, refining that solution iteratively, time and time again, until you have something that is really robust. And you don't need to be good at drawing to do design. You don't need to be good at writing little stories. A lot of these tools are intended to be used very quickly with minimal effort, and they can be learned by anyone. And so I strongly encourage you to use some of these techniques in your work. Thank you.